Hello and welcome. The Fluent Meshing user interface has many features and tools to help you create high-quality volume meshes for your model. The user interface is made up of many components that allow you to choose a workflow, control the display, modify what gets selected on mouse clicks, and much more. In this video, we will go over some of these commonly used options of Fluent Meshing user interface. So let's get started. Let us begin with opening a new session of Fluent in meshing mode. Upon opening, you are taken to a window that has many user interface components. There is a menu bar, the ribbon, the graphics window, some toolbars, the console, workflow, and outline view tabs. The ribbon can be collapsed by clicking the Hide Ribbon button to allow more area for the graphics window. Different sections of the window can be made smaller or larger by pulling on the borders. In the top right corner, in the Arrange the Workspace menu, there are some predefined window layouts available, and you can always revert to the default workspace arrangement by choosing the Meshing Default option. In the Workflow tab, you can access the guided workflows that are designed to make it easier to generate a volume mesh, or you could create and save a new tailored workflow for your models. The three buttons here allow you to load an existing workflow, save a new workflow, or reset the workflow that you are working with. On choosing a workflow, the task list displayed in the upper half of the Workflow tab walks you through the process of creating a valid volume mesh, beginning with the import geometry or mesh. You could insert tasks at any point in the workflow to modify them to suit your modeling needs. This can be done by right-clicking at the location where you want to insert the new task, going to Insert New Task, and clicking on the appropriate task. The Insert New Task is context sensitive, and only those tasks that are relevant at that point in the workflow can be selected. User inputs required for active tasks in the workflow are displayed in the lower half of the Workflow tab. By clicking the Help button next to the entries, a description of the specific entry is displayed. If you need more information, click on More at the bottom, which will open the user's guide in the browser. You can also save your mesh at any point by going to the File menu and choosing to write the mesh. Also, an existing mesh could be read into the Fluent Meshing session using the Read option. With the Preferences dialog box, you can specify the global settings related to appearance, graphics, and navigation that are applied whenever you launch a Fluent Meshing session. To read or write mesh files, Fluent uses the Common Fluids format CFF by default. Mesh files saved using CFF will have .msh.h5 added to their file name. Optionally, you may use the legacy compressed format, which will have the suffix .msh.gz. However, it is recommended to save files using the default CFF option, as CFF files offer much better read and write performance compared to the legacy files, and can be post-processed in CFD Post and Nsight, as well as in third-party products. Let us go to the window with an imported model to demonstrate other options. The ribbon contains options to manage the graphical display and select objects. You can switch to the solution mode from the meshing mode by clicking the Switch to Solution button. Ansys Fluent loads the generated volume mesh to the solution mode where users can set up the CFD model. A clipping plane can be inserted to crop your model along the X, Y, or Z plane to allow you to view the interior details of the mesh. You can move the clipping plane by using the interactive slider as shown. Alternatively, you may use the clipping tool triad, which allows the manipulation of the plane directly in the graphics window. Select an element of the triad, hold down the mouse, and then drag to move or rotate the clipping plane in the graphics window. You can revert to the whole model being displayed by unchecking the Insert Clipping Plane box. Another approach for visualizing the model is to make one or more zones transparent using the transparency option in the display group. You select the zones you want to make transparent and click on Transparency. To remove the transparency, click on the Transparency option again. The graphics window displays your model as per the existing display settings. The axis triad is indicative of the orientation of the model. If you left click on an axis, the model will be oriented in the positive direction of the axis. If you want the model to be oriented in the negative direction of the axis, then just click on that axis. Using the white rotational arrows, you can rotate the model by 90 degrees in the clockwise or counterclockwise directions. Clicking on the cyan sphere will return the model to the isometric view. You can freely rotate the model by clicking and holding in the vicinity of the triad and moving the mouse around. The console is located below the graphics window and is generally used to read any printed warnings or errors, including information related to the mesh quality. The toolbars around the graphics window provide some shortcuts to perform common tasks. They can be docked at any convenient location in the user interface. As mentioned earlier, you can revert to the default workspace arrangement by choosing the meshing default option as shown. The pointer tools change the role of the left mouse button. You can assign it to rotate, pan, zoom in and zoom out, or zoom an area of interest. Fit to window readjusts the overall size of the model to fit within the graphics window. The set view contains a drop-down of views, allowing you to display the model in an isometric or one of the orthographic views. You can disable the reflections by clicking on the reflections button in the graphics effect tools. Similarly, you can control the shadowing effects and the ground grid display beneath the model using the options shown. In the visibility tools, you can display the ruler, which can give you a sense of the sizes of various features of the model. Also available are the options to turn the axis display off and display the title. If you want to save a picture of the active graphics window, you can do so by using the Save Picture option in the Copy tools. Fluent Meshing also provides the ability to copy the currently displayed picture into your clipboard for future use. The Selection Filter toolbar allows the users to select nodes, edges, faces, or zones when you right-click on the model. The Position filter displays the coordinates of the point you click on the model in the console below. If you activate the node filter, the node will be selected, and same is true for edge, face, and zone filter. To deselect your selections, you can either use deselect last to deselect one by one starting from the latest selection, or clear selection to clear all selections at the same time. The keyboard shortcuts for deselect last and clear selection are escape and F2 keys respectively. To calculate the distance between two selected nodes, you can use the distance option in the examine group. This can be useful to figure out the values to enter for mesh sizes. So, to summarize, in this video, we learned about the different components of the user interface and discussed some of the commonly used options which could be helpful in the process of meshing in Fluent. We learned how to select workflows and how to use clipping planes to view the inner details of the mesh or model. Also, we saw how to control the display in the graphics window and the different options available in the toolbars. This brings us to the end of our video.